Alright, so to start off this problem, we need to find the total heat energy loss from the molten iron. So we have Q equals mc delta T. That's the formula we're going to use. So Q is going to equal 0.02 kilograms. That's converted from the 20 grams. And you times that by 825 joules per kilogram degrees Celsius. That's going to be the specific heat. And the change of temperature is going to be 1540. That's the boiling point. The melting point. Minus 1600. That's the initial temperature given.
Okay.
Alright, so this is going to be the energy required to change it from liquid to solid. So it's 0.02 times 200,000 joules. And you're going to add that to 0.02 times 450 joules per kilogram Celsius. That's specific heat times TF minus 1540.
Now we're going to solve for the energy that the container and the water get from the iron being poured in. So it's 0.50 kilograms of water times 4,200 joules per kilogram degrees Celsius times T final minus T initial, which is 25, plus the 4 kilograms of the iron container times 450 joules per kilogram degrees Celsius times T final minus T initial, 25 again. Okay, so when you simplify these two equations, you get negative 18,850 minus 9TF equals 33,900 TF plus 97,500. And then you solve for TF here, you get 39. And TF is equal to 29.8 degrees Celsius. So that's going to be your final temperature of the system. So now the second part of the equation asks us how much extra molten iron is needed to evaporate half of the water. So to find the amount of energy needed to evaporate half of the water, we have the bucket times its specific heat, and then the temperature change is going to start or it's going to end at 100 degrees Celsius because that's the temperature that water evaporates at, and we're just going to subtract the temperature we just found because it's how much extra iron is needed. And then we have the mass of water times its specific heat times its temperature change is the same as that of the iron bucket. And then the amount of water that evaporates is only half, so we have 0.25 kilograms times the heat of fusion of water. And there is no temperature change in that. And when we solve for that, we get 8,000, this number. So that's the amount of energy needed to evaporate half of the water, and we set that equal to some mass of iron times its specific heat in liquid form. And the temperature change, it starts out at 1600 degrees Celsius minus its melting point. Then we add that to the mass of iron times its heat of fusion, added to the same mass of iron times its specific heat in solid form. And then the temperature change starts out at its melting point and goes to 100 degrees since the whole system ends at 100 degrees. So then solving for that, we get
times the mass of iron, and we can set that equal to the energy needed to evaporate half of the water. And solving for mass, we get 0.96 kilograms.